You ready?
Yep.
Okay. Today we're going to discuss a little motor known as a shaded pole motor. These things are common. And this one's made with a single coil of wire, which is pressed into a stack of laminations or a frame. And you can see at my fingertip there that the thing is just pressed in, the coil's just pressed in, so it makes it very cheap to build. And of course, they come cheaper and more expensive versions of the same thing. This one has shaded poles, which is shorted turns of copper wire here and here that make the magnetic field sweep, so it gives you a field that will make the motor actually turn. And this one's got fairly thick laminations. This one has fairly thin laminations. This, of course, costs more money. Also, this has screws, so you can take it apart. This one's whacked together with some rivets. Now, I've wound 10 turns of wire on this one's coil here so we can find out what the turns per volt of this motor is. A little later in the video, you'll see why we're doing this. Okay, I'm going to plug it in. We have a watt meter here that tells us a bunch of things. It tells us the power factor, tells us the current, 0.18 amps, tells us the watts it's using, just sitting there running, tells us the voltage, 234, and the frequency. And we have a voltmeter over here hooked to the coil. This voltmeter is saying that we have 0.548 volts, 0.548. So the turns per volt is 0.054 turns per volt. Okay. Now I'm going to plug the other one in just to prove a point here. Okay. You notice it runs almost silently. You can barely hear the thing going. 0.13 amps, 13 watts. That's a huge difference. Almost 25% less power being used by this motor doing the same job. Okay, let's look at the paper, see some calculations over here. The second motor, the one with a thicker stack of laminations, 13 watts versus 18 for the cheapie. Power factor is higher, 0.44 versus 0.41. Current, of course, is a little better, 0.13 amps versus 0.19 amps. So your reactive current's better when your power factor's better. Okay, we took the turns, 10 turns, 0.558 volts. At the time I took these readings, it was 238 volts, 0.058 turns per volt, 1/10 of that reading. Gave me a total of 4,103 turns. If we wanted to make this motor run on, say, I don't know, 15 volts, 238 volts divided by 15 volts is a transformation ratio of 15.87. Take the 4,103 turns, divide by 15.87, you need 258.5 turns to make the motor run at 15 volts. And I have done just that with another motor. Very similar motor. It's the same as the first one, as the little thin one here. Okay, stop recording for a second. We'll set this up.